Good day, everyone. In this episode of Crash Physics for SS2, and which is the last episode for this course, we are going to be dealing with pressure in fluids. I implore you to watch to the end of this video to gain as much as possible. The simple concept of pressure is that pressure is a force which acts perpendicular to the surface on which is applied. So pressure is like the amount of a perpendicular force acting on a unit area of a surface. That is the simplest way we can define pressure. As you can see, in this case, you can see a cylindrical surface perpendicular to a flat plane. Now, anywhere we deal with perpendicular forces, there's a high chance that pressure is involved because pressure as a force itself is perpendicular. So when this cylinder is perpendicular and a force is applied along the plane of the cylinder and it's acting on a particular area of the plane on which it is pressed upon. Now that constitutes pressure. So now we formally define pressure as the perpendicular force per unit area acting on the surface, and symbolically we can represent it as P equals F by A. It is the ratio of force to area in a particular machine or a particular surface or a particular plane. So force is measured in newtons and the area is measured in square meters, and the system international unit of pressure is newtons per meter squared, and it's a derived unit from the force, and the area of such is an area. There is one undisputable fact that we know about pressure, and that is the fact that pressure increases with increase in depth of a fluid. Now this episode is about pressure in fluids. Now this pressure exerted by a liquid increases as you go down to the end of the liquid, and this can be shown by this diagram. You can see that when you make holes at different heights on the side of a tall vessel placed vertically on a table or a raised platform, and then when you fill the vessel with water and then you open the holes, you see that being the water being ejected from the lowest hole will travel a greater horizontal distance because of the greater force. So this just like the motion of a projectile. When it is projected downwards, it's the more the initial velocity. So the water has more energy. Now this energy is as a result of the increase in the force, and this force is directly proportional to the pressure. So that means the energy is as a result of the increased pressure. There is one fact, and that fact is that air has pressure. So let's look at this picture to show that air actually has pressure. So we can demonstrate that air exerts pressure by the following simple experiment. So you pour a little water into a tin walled can, such as a kerosene tin, and you boil the water for a few minutes so as to drive out the air in the can through the steam produced. Now you remove the flame and insert in the opening an airtight rubber stopper. You pour some cold water on the can and observe how the tin collapses. So this diagram shows how the tin collapses after you poured water on the tin. Then you can explain the collapsation of the collapsing of the tin by showing that when the cold water is poured on the can, the steam inside it condenses and leaves a partial vacuum in the can. So because of this, the external pressure is no longer counterbalanced by the pressure within the can. So the can is then crushed by this excess air pressure. So this shows that air actually exerts pressure. The fact that pressure exerts force can be applied in a various variety of instruments and devices. Now the siphon is one application of atmospheric and gas pressure, and the siphon is a device used to remove liquids from receptacles which cannot be lifted or easily reached, or cannot be otherwise emptied more conveniently. Liquids can only be transferred from points at higher levels to points at lower levels. Now, basically, it consists of a bent, flexible tube with one end dipping below the liquid surface in the vessel of the liquid, and the other end is at the point of lower level. So, how it works is that as long as the tube is filled with liquid, there will be a continuous flow from the higher point to the lower point. So there's a reason for that. It's because of the pressure difference between the higher point and the lower point. So, but there are some conditions. The tube must be filled by the liquid for this water to flow from this container to the lower position. It must be filled with liquid. So basically, the water has to rise a height of h1, and it has to descend a height of h2. So as long as that height h2 is greater, and as long as that height h1 is less than the barometric height of the liquid, so the liquid will be able to move. So we'll talk about barometric height. Is basically the amount of the height of liquid that can be supported, or the column of a liquid that can be supported by that same liquid. So the column of water, for example, that can be supported is 10 meter at atmospheric pressure, and so on and so forth. Another application of pressure is in the working of a syringe, and this syringe is a device that consists of a piston which fits tightly into a cylinder as shown. Now the cylinder has a nozzle at one end, and basically when you pull the piston downwards, you are ejecting the fluid, and when you pull the piston backwards or towards you, you are um, you are drawing in fluid. So when the nozzle is dipped into a liquid and the piston is pulled up, the atmospheric pressure forces the liquid up the cylinder. But when the piston is pushed downwards, the liquid is forced out or ejected, and this is because of the excessive pressure, which produces a force that pushes the liquid outwards. There's one obvious phenomenon that happens, whereas if you push a piston down a spherical plastic bulb with holes all around, now you notice that the water that flows through those holes are coming out with the equal force. They are coming out in all directions with equal force, and this is because of Pascal's principle. Now this Pascal's principle, it is simply the law that says that the pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. So basically what this means is that the force that you are exerting is divided equally among each of the holes along the surface of this spherical bulb, and that's why the water will be coming out in all directions. Just like other laws in physics and principles, the Pascal's principle that pressure is applied equally to all parts of an enclosed fluid can also be seen in the working of a motor car foot brake. Now, a motor car foot brake is basically how the motor car how the brake works. So basically, this is how the brake functions, and this is a diagram demonstrating that. So the car brakes uses the hydraulic principle to transmit pressure from the foot brakes to the foot pedal to the brakes. Now, such a system slows down each wheel equally, thus reducing the danger of skidding. So the device is as shown. When the brake pedal is pushed forward, the motion of the piston in the master cylinder compresses the oil inside the tubes. So you can see the oil. This is the reddish brown colored part of this picture, and then the shoes now push on the revolving brake drums fixed to the wheels. So you can see the revolving brake drums. Now when the shoes push against them, the brake drums also push against these wheels. So basically that causes friction. Now when the pressure is released, a return spring, so there's a return spring actually, and that return spring connected to the brake shoes pulls them back away, so the wheel is now free to rotate. So this is simply how the wheel of a motor car is braked, how you apply the braking principle of pressure to brake the motion of an automobile, not just a car. Now basically pressure is a very important concept because it's applied in very major ways in our everyday life. So you can also check out um, instruments used to measure pressure like the YouTube and the Hairs apparatus. Now basically the YouTube is a device that is used to measure the relative density of liquids. Now this relative density is also related to the pressure exerted by each of the liquids depending on the air columns. So you can check out Google or YouTube on the working principle of a YouTube, and a health apparatus. But as in conclusion, what we're talking about today, we're talking about the fact that pressure is a perpendicular force per unit area. We've also talked about the fact that Pascal's principle states that pressure is exerted in all directions of a fluid. So I hope you've enjoyed this video. If you have, please don't forget to like, share, and subscribe. And I hope to see you next episode.